Welcome to the dojo, ninjas! What's up, guys? I'm going to show you a quick trick for this integral to solve it in just a few minutes. And if you stick around, I'm going to have a fun black belt challenge for you to see what belt you earned in the dojo. The first thing I want you to recognize is, do you remember how tangent of x equals sine of x divided by cosine of x? The reason why I'm bringing this up is because by inspection, if you look at the original integral, we have three different trigonometric functions we have to deal with. Imagine if we only had one or two, so that way we could do a nice U-substitution. The reason why I'm showing you tangent of x here is because if you manipulate this, with the original sine of x term I gave you in the problem above, we're going to go ahead and replace it with tangent of x times cosine of x, giving you this new integral expression. And I know it doesn't look easier because we still have three different types of trigonometric functions, but there is also another thing you can do here with this cosine of x term. Do you see it? I'll give you a second or two. Okay, because this integral already has a secant term in there, it would be nice to write this cosine of x in terms of secant of x, right? That way we are only left with two different types of trigonometric functions. So we know that cosine of x is the same thing as 1 over secant of x. I'm going to go ahead and substitute that in here, because now we can just multiply everything through, and that gives us an integral where we only have two different types of trigonometric functions to deal with. So hopefully it's more clear to you now that we can go ahead and do a U-substitution. And before I do that, if you're finding value in this and you want to support me making more content for you, ninja smash that subscribe button. And if you want a fun break between your exams to keep your mind sharp, check out my free game in the description below for your iPhone and iPad. So what I'm going to do here now is I know the derivative of tangent of x is secant squared of x. And that actually shows up in this integral, which means I can just let u be my U-substitution where we have tangent of x. That way when you take the derivative of both sides, secant squared of x dx in that integral all goes away and just becomes du, right? This gives us a very nice polynomial integration problem now, because just by inspection it's very simple. You should know that it's just 1/3 u cubed plus c. I don't like showing the plus c until the end, where I put back in everything in terms of x. We know that u equals tangent of x here, so I'm going to go ahead and do that, giving us this final answer. And so my challenge that I had for you for the dojo was, I want to know in the comments what belts you earned. If you got this question right, congratulations, you get at least a white belt. Now, if you want to get a red belt, did you happen to catch the original trick I used in the original problem where I remembered that tangent of x equals sine of x over cosine of x? That allowed me to save time on this integral, so you get a red belt for that. And then for you master ninjas, did you get a black belt? The way you can get it is if you can tell me in the comments below what the domain of this final answer is.